Swayam Prabha. Digital India. Educated India.
So, last class I have discussed that how to measure the ground motion parameters, and then what is the basic equation of motion, and then I have started about the different ground motion parameters. I have discussed about the amplitude parameter, that those are acceleration, velocity and the displacement. Now, today I will start about different other amplitude parameters, or basically I will continue the ground motion parameters. So, and then I will discuss about the frequency content parameters and then the duration of the earthquake. So, first the other amplitude parameters, because we have discussed the three common parameters, amplitude parameters, that is your acceleration, velocity and the displacement. In addition to that, there are other amplitude parameters are there. So, those first one is the effective acceleration. So, what is effective acceleration? The acceleration which is most closely related to the structural response and damage potential of the earthquake. So, that sometimes use of peak amplitude has very little effect on structure with low natural frequency. So, if the structure has a very low natural frequency, in that case if I use the peak amplitude, then we will get a very little effect on the structure. So, these time histories are characterized by single cycle peak amplitude much greater than the amplitude of other cycle than usually occurs for high frequency. So, what is meaning that? Because suppose if I use such a motion parameter, so that when suppose your this motion parameter is like that, there is a very high single peak amplitude, okay, very single peak amplitude which is much greater than the other amplitude, but and it is usually occur at very high frequency. But if you consider that maximum amplitude which is occur at very high frequency, then that has a very little effect. If I consider this one, that has a very little effect on the structure whose structure with low natural frequency. So, that's why always using peak amplitude is not a good idea. You have to decide when you will take that and when you will not, because then that is the effective acceleration you should consider in that case, the acceleration which is most closely related to structure and damage potential of the structure. So, in this case here your amplitude, this peak amplitude is very high, but in the other case where there is number of similar type of amplitude peak, okay, it will create more significant effect compared to this one, because it is only C which is very high and is occurring in a very high frequency, rather than the second one whose peaks are low, but there is a number of equal amount of peak. Okay, so that means you have to decide which one you will consider for your structure. So, that is your effective acceleration. The next one, sustained maximum acceleration or velocity. So, sustained maximum acceleration is defined that this is the 3 or 5 cycles. So, that means acceleration or which is sustained for 3 cycle or 5 cycle, then that is called that is defined as third or fifth highest value of acceleration in time history. What is the meaning of that? Suppose if we have a acceleration and time history. So this is time, this is my acceleration. Okay, so we have this type of time history. This is one. So that means here these three acceleration, this acceleration is sustained for 3 cycles. Okay, so these 3 cycles, so then it is called, if it is sustained for 3 cycles, then this acceleration is called the third highest value of acceleration in the time history, if it is sustained for 3 cycles. So that is called sustained maximum acceleration. Similarly for velocity also, if it is sustained for 3 cycles, then it is 3 highest or third highest absolute value of acceleration. If it is sustained for 5 cycles, then it is called fifth highest absolute value of acceleration. Clear? So that means if this 3 cycle acceleration, which means acceleration which is sustained for 3 cycle, and that is defined as the third highest absolute value of acceleration in the time cycle, time history. And if the fifth cycle acceleration, sustained fifth cycle acceleration means if it is sustained by fifth cycle, then that is termed as or defined as fifth highest absolute value of acceleration. So that means the 3 cycle sustained acceleration is defined as third highest value of acceleration, absolute value, and fifth cycle sustained acceleration is defined as fifth highest absolute value of acceleration in the time history. Clear? It is defined as. So that means if a cycle is sustained for acceleration is sustained for 3 cycle, then it is called 3 cycle acceleration, sustained acceleration, and that is also defined as third highest absolute value of acceleration in the time history. Or if our acceleration is sustained for 5 cycle, then it is called 5 cycle sustained acceleration, which is defined as fifth highest absolute value of acceleration in the time history. Clear? Now, effective design acceleration. What is effective design acceleration? It is the remaining peak acceleration after filtering out acceleration about 5 to 9 hertz. So, if you filter out the acceleration about 9 to 8 hertz, then the remaining peak acceleration is called the effective design acceleration. So, that there are different definitions, this is one of them. The next one, it is the 25% greater than the third highest absolute value of peak acceleration in the time history obtained by filtering time history. So, that means you filter the time history, then in that time history the third highest peak acceleration you identify, that means the third 3 cycle sustained acceleration. So, that is termed as third highest peak acceleration. So, that you identify, and then you increase it by 25%, 25% greater than that value, that will be your effective design acceleration. Clear? So, now next one I will go to the, so now previously our parameter that I was discussed about the amplitude parameters. Now I will go discuss about the frequency content parameter. So, those are also important. Not only the acceleration amplitude, the frequency content parameters are also important. What is that? The distribution of amplitude of a ground motion among different frequency can be described by frequency content. So, that means the ground motion among different frequency, distribution of amplitude of the ground motion among different frequency, because it has different frequency, can be described by frequency content. What is that? These are, there are also different parameters. So, these are, first one is the Fourier spectra. So, what is Fourier spectra? Fourier spectra is a plot between Fourier amplitude and the frequency is known as Fourier spectra. Your frequency or time period. here it is a period, time period. So you can see this is Fourier amplitude, y-axis, and this is the time period. This is your, this for different two sides is called the Fourier spectra. When I plot the Fourier amplitude with time period or the frequency, okay, then it is called Fourier amplitude, Fourier amplitude spectra. So you can show for two different sides. Now a narrow spectra indicate that motion has dominant frequency, that means smooth, almost sinusoidal in nature. So if it is a narrow, that means narrow spectra means that one particular this frequency is smooth or it is dominant, motion has a dominant frequency. The narrow means there is one or frequency that is dominating that motion. Okay, if it is narrow, that means it is smooth or it is almost sinusoidal, where is the dominant frequency is there. But if it is spectra is broad spectra, which indicates that motion has a variety of frequency. If it is narrow, then motion has a very dominant frequency, and if it is your broad spectra, then it is indicate that motion has a variety of frequency. That means that motion is a irregular type irregular time history type. Okay, that means if it is a narrow, then it is almost sinusoidal time history. If it is a broad spectra, then it is irregular time history. Now here few terms I use, that what is the Fourier spectra. Now discuss about what is Fourier spectra. Or first we will discuss what is Fourier series. Then we will discuss about the Fourier spectra from there. So Fourier series is, let me discuss first the Fourier series. Okay. What is Fourier series? So Fourier series is basically the breaking down a complicated loading function into sum of series of simple harmonic loading function. That means, for example, earthquake loading. It is not a simple harmonic motion. It is a harmonic motion. It is a complicated loading function. So what we will do, we will break that complicated loading function into number of simple harmonic loading function. Okay. Then principle of superposition is applied to get the solution for this harmonic loading, and those to be used to compute the total response. Suppose if I want to get the response of an irregular loading, if I want to get the response of a irregular loading. Later on when I will discuss about the response spectra, I will discuss what is response, what is maximum response. So right now if you want to determine the response of a irregular loading, then what I will do, first I will divide, I will break that irregular loading into number of simple harmonic motion. Then I will use the principle of superposition to get the solution for that harmonic loading, and that solution will be finally used to get the response of that irregular loading. Clear? So now if I write the steps for this Fourier series, so that means first, suppose this is my time history. Okay, you can in the, this is time, here I am not writing, this can be your acceleration, this can be velocity, this can be your displacement. So I am just writing that this time history loading. Okay, or this is your loading, if you say, that means here the time history loading will be like this. This is the your time history loading. Which is not a harmonic motion. So that one I will divide into number of harmonic motion. that I will break with a number of harmonic motion. Okay. Because I want to get the response of this time history loading. Okay, and so on. So this is the time history loading as a sum of series of harmonic loading. This is the sum of series of harmonic loads. Okay. Then what I will get? I will get the solution for harmonic loading. And then I will calculate the response for each harmonic loading. I will discuss how to later on how to get the response of harmonic loading, how to or the different types of loading. So then when I will get the solution for harmonic loading, then I will calculate the response of each harmonic loading. Then from here I will get the sum of series of harmonic response. Now it was previously harmonic load. This was time history load. Now it will convert to harmonic load. Then I will get the solution. I will get the response of each harmonic loading. Then that response I will plot here. Okay. Basically these are harmonic loading, so that means sometimes maybe not as per scale. So, but these are harmonic loading because I am not able to draw. Actually, that is the reason. And so on. So this is initially it was sum of series of harmonic loading. This is sum of series of harmonic response. Okay. Now from here finally I will get the final response of that initial time history loading. Okay. So this is the summation of, now you sum that, then you will get the harmonic summation of harmonic loading, harmonic response to produce time history response. Okay, so what is the steps for this Fourier series case? That first, time history loading will be converted to sum of series of harmonic loading, then you will get the solution and you will calculate the response of each harmonic loading, then we will get the sum of series of harmonic response. Then by using that sum of series of harmonic response, we will produce the time history response. So time history loading will be converted to time history response by these steps. Clear? So that means Fourier, that means in a case of Fourier series, it can represent in case of summation of this harmonic loading. So this is the steps. So later on I will show you how I will get the response of each harmonic loading when I will discuss about the response spectra. So now here I can see that if I express the Fourier series in trigonometric form, so Fourier series can be expressed in trigonometric form and exponential form as the previous case also. Previous case also we express it that time history in trigonometric form and the complex notation. Okay. So here also first I will write it in trigonometric form. So that any function xt that can be written as a0 plus summation of n equal to 1 to infinity, that is a n cos omega nt plus b n sin omega nt, because it is summation of n number of harmonic loading. So and this is the expression of one harmonic loading expression that I have discussed, that it is equal to your ut is equal to a cos omega t plus sin with b sin omega t. So that way I can retain, but it is summation of n number of harmonic loading. Okay. Now where Fourier coefficient are written a0 is equal to 1 by tf 0 to tf xt into dt. So where tf is the period, where I have discussed what is period of motion. Okay. So this a0 is basically the average value of xt, that function over from t equal to 0 to t equal to tf. So from a time period 0 to tf, this is the average value of that function over that time period. And an is equal to 2 by tf 0 to tf xt cos omega nt dt. Okay. And your bn is equal to 2 tf 0 to tf xt into sin omega n t dt. That is an and bn expression I will get. Now I know that my t is equal to 2 pi by omega, or omega is equal to 2 pi by t, and omega n will be equal to 2 pi n divided by tf. Okay, because this tf time is been divided by n number. So now del omega that will be equal to 2 by Tf. The del omega is 2 pi by Tf. Okay. So now I can write that here that ut, you know, that is a cos omega t plus b sin omega t, because that I have written. So that I can write how? A sin omega t plus phi, where a will be root over a square plus b square and phi will be tan inverse a by b. A similar way, if I, because I have now expressed this in this way, so now if I express this expression of xt in this form, how I can express? So this xt I can express as c0 plus summation of n equal to 1 to infinity and cn sin omega t plus phi n. Because this part I have written in this form, because I can write, okay, this is equal to, if it is a cos omega t plus b sin omega t, then I can write is a sin omega t is phi. So here this equation, it is written c, this c is equivalent to a actually, cn, and sin omega t, this is phi n is equal to phi. Okay. Now if I write this expression like this, that my xt, the same expression here writing that, then this is equal to n equal to 1 and infinity cn sin omega nt plus phi n, this will be phi n, then where c0 will be what? C0 will be a0, okay, and cn will be, what is cn will be? Here it is cn. Cn will be root over n square plus bn square. So cn will be root over n square plus bn square, because this is your expression. So this is converted to this. So that means this will be n square plus bn square, and phi n will be tan inverse an by bn. Okay. So this Cn is called the Fourier amplitude. Okay. The Cn is called the Fourier amplitude. And phi n is called the Fourier space phase. So now we have that expression. Now if I plot, then Cn versus omega n plot. Okay, Cn versus omega n plot, that is called the Fourier amplitude spectrum. Okay, so that is thing I am talking about. This is Fourier spectra. So this is the plot between Fourier amplitude and the frequency or time period is known as Fourier spectra. So here this is the plot between Cn here, Cn and omega w plot, that is called Fourier amplitude spectrum. Okay, or again if I plot Fn versus omega n plot, So that is called Fourier phase spectrum. So I think it is now clear to you that when because what is Fourier spectrum? It is plot between Fourier amplitude versus frequency, or here I have discussed that it is plot between Cn versus omega n. It is the plot between Cn versus omega n. Then this is called Fourier amplitude spectrum. So here I have expressed this Fourier series in trigonometric form, but it can be expressed in exponential form also. Okay, so that I will discuss later on. Right now you know what is the Fourier spectra. It is the plot between Cn versus omega n. So in the next class I will discuss other type of frequency content parameter, because I discussed Fourier spectrum. So there are two others, that is the power spectrum and the response spectrum. So response spectrum is most popularly used frequency content parameter, and there I will discuss what is how to determine the response of a harmonic loading or different types of loading, and then from there how I will get the response spectrum. Thank you.